So for this meeting, I wanted to talk about some of the MEP tools that are built into Vectorworks. In my workspace, there's an MEP palette. Looks like this. Let me just pull it out. I'm not going to go over all the tools by any means. Mostly, I wanted to focus on how useful these can be for design purposes, not just documentation. I don't know if we're going to need the full hour and a half, but hopefully this will be valuable. So I'm going to start with a residential project that we did a few years ago where we had to use, where we made use of the ducting tool rather extensively, but also want to touch on the switches and outlets that come to play here as well. Not just for kind of the prosaic creating a reflected ceiling plan, though, I mean, that's nice. And so this particular project, the clients had approached us and they were inspired by a house they had seen that had a lot of these kind of sawtooth roofs with vaulted spaces. And that's very cool and very happy with how the house turned out. I think it's on my website if anybody wants to see actual photographs and not just a model. But you don't necessarily think about how you're going to duct something like this. Maybe not on the first concept design. And so, of course, it's always a good idea to think about these things ahead of time. But in this case, we've got these nice two little sawtooth roofs. They're at slightly different pitches. But then we have this, the main mass of the house is this sort of L shape where you can see that we've got this valley that's fairly obvious. And more to the point, we wanted to vault that space. That was important to the clients, create this sort of clear story over here. And you can see the tail end of this expressed steel beam that's supporting the roof, and that's an important design element. And all of these things are great and not the kinds of things that mechanical contractors love to see. So just to look at some of the specific challenges, if I go underneath here, right, you can see how all of this space, from this worm's eye view, you can see how all of this space is vaulted. And again, that's very cool, but it makes ducting a bit of a challenge to kind of get everything in there. The sawtoothing is maybe not as much of an issue as you might think. We sort of turned that into an opportunity. You can see the duct here is modeled in pale blue. And if I turn off the clip cube for a second, just to orient you. Oops, sorry, wrong save view. There we go. So we're just bringing that duct in from across the house over the kitchen. We have a bit of a fur down that sort of lines up with the cabinetry and the counter below. That's actually kind of nice. In the primary bedroom, we continue that fur down, and by running a window right up to the underside of that ceiling, makes it quite intentional and doesn't just feel like we threw a fur down in there just for the sake of running a duct. And then that gets us back in here to a little bit of ceiling space over the toilet room, which you can't see in this section, but it's in line with this little alcove here. And then we could just throw into the primary bathroom. So that wasn't too terribly challenging. Probably could have figured that out without the benefit of actually modeling the duct. But where we get ourselves sort of into a tight spot here is with the upright HVAC unit. I've just highlighted that in orange. That's in a closet. plan. So that's right over here in this closet by the entry. We've got a hallway. We've got a low ceiling in this study over here, so we can just run the duct over. But again, where we run into trouble, where we have a potential for a bit of an issue here, is with that beam and that valley are creating a bit of a pinch point right around here, as you can see. So we're trying to get from this mechanical unit, air handler, all the way across to the duct run in the sawtooth that I was showing you earlier. And so it was really helpful to be able to model all of that duct work. Now, of course, this is a residential project, so particularly for something of this scale, we're not necessarily going to have an MEP engineer. We'll have an MEP contractor who's coming in after the fact. Once all of this design work has been done, it's uncommon for MEP and contractors to be involved. But by modeling the duct using the duct tool, in each of these is a specific duct element. So the duct tools give you, let me go ahead and open my object info palette. Here's a duct, an HVAC vertical elbow. I didn't bother drawing the ductwork from the top of the unit. Here's an HVAC straight duct. So all of these live here, right? I've got a straight duct right here. I can do a transition with a duct. I can do an elbow. Also have a vertical, that's a diffuser. Here's my vertical duct tool. And this icon is a vertical elbow. So that's how I modeled this. And so here you can see I've got a collision with my beam. So, obviously I need to drop that. 8 inches is probably too much. Drop it by 2 inches. Something like that. And this is just an elbow duct. Let's go ahead and isolate that with the clip cube. Here's an elbow duct right there. And so by using the duct tool, I can specify a width and a height. I can get cross-sectional information. I can eventually schedule all of that. And you can see that I haven't been too fussy about making sure that this elbow, for example, lines up perfectly in this case. I just want to make sure that I've got a plausible path for the ducting to get me from this side of the house all the way over to the other side. And I think these ducts were sort of thrown in an earlier phase, and once we were comfortable with the design, we didn't sort of update the duct work with every little nudge of a wall or whatever. So some of these may not line up perfectly. They may have kind of been jostled along the way towards CDs. So just as a design tool, just this kind of little schematic work is pretty helpful. Of course, you could do that with an extrude along path, but then you start to get complications with changing the diameter. See, what you would end up doing for a complex path like this is making a series of extrusions or extrusions along path. It's much easier just to use the tool where you can specify, the length and the profile, whether it's rectilinear or round or oval, and then give it a width and a height and a length. So, and then you can either just do these in 2D or you can do them in 3D. And obviously here it's critical to do those in 3D. And it turns out, by the way, that when we ended up doing the project, we did have a second option, which is the option that we ended up taking. which is this ridiculously tiny attic space that we had given ourselves in the utility room. And I think we may have modeled the ceiling a couple of inches higher. We might have pulled that ceiling down by 6 inches or so. And so the contractor, once everything was framed, the HVAC contractor decided that they were perfectly happy to squeeze a horizontal unit into this space. There's a scuttle right nearby to get everything accessed barely. If your contractor ends up being a small child. So it turns out we didn't really have to worry about that pinch point, but I was never 100% comfortable with this attic as we were in design. And so I wanted to make sure that I had a second option. So this is where that tool was really kind of helpful. And I'm going to get more into sort of the nitty gritty of the specific tool on another project that I'm going to show you in a few minutes. But I wanted to start with that. And there have been a couple of instances where this kind of schematic level modeling's really been helpful. Before I kind of move on to a tangent, any questions so far or comments? Or why didn't you think of this, Francois? Oh, let me check the chat. Nope, nothing in the chat. All right, well, that's I think that's permission for me to proceed. So while I've got this view, I want to look at another tool in this palette. There's a switch tool, and there's an outlet or a receptacle tool, more specific, more correctly. And these are very, very simple little tools. If I look at my RCP, right, all of these, this outlet, this receptacle, these switches, these are all made with this particular tool. And the nice thing is the model isn't super detailed, right? Like this is very, very basic, but it's a hybrid object, right? So I can specify a height above the floor. I can give it a label. I could schedule it if I wanted to, schedule my outlets. Unlikely. So it's a very basic, simple little tool on this palette. Used to in back in the day, just make a symbol with a line and an S through it, or circle in 2 or 3 lines through it for my switches and outlets, respectively. But the problem is that those don't show up in 3D, and having a hybrid object that gives you both 2D and 3D information, 2D obviously for your CDs and 3D for your models, really useful, particularly when it comes to things like outlets and switches. I mean, I know that's very, very prosaic, but the residential code is such that when you do a kitchen design like this, where you've got this big expanse of glass, this is also, like I said, this is on our website. So if you look at the photos, you'll see there's lots of really great tile and finishes. And the last thing that you want to do with a backsplash like this is to stick a couple of outlets in there. So with kitchens and islands, we're always sort of trying to work out how are we going to meet our IRC code requirements for access to outlets. So we've sometimes done like a 2-inch gap below the top of the counter and the bottom of the counter and the top of the cabinetry, and stuck simplex outlets in those to meet those requirements. In this case, we've got a hidden panel where I'm going ahead and showing the 2 outlets that go behind that sort of flip down panel at the sink for access that the inspector allowed us. Not every inspector will let you get away with that. And then for the backsplash here, what we have is we just have a quad mounted that's built into this floating shelf. And you can see right here under the object info palette, I'm calling that out as a quad. And I'm calling it out Vectorworks has the option to give me a floor, wall, or ceiling location, and it will model the little 3D artifact differently depending on which one you pick. So I picked a ceiling location, and then I just set the height at 54 inches, which is the bottom of the shelf, and you can see that it's right there. So that meets our power requirements. Whoops, inadvertently moved that. There we go. And then it's nice to see where the switches go in 3D so that as you're looking at your model, it sort of causes you to think about some of these things that you might otherwise ignore until you're in the field. And then, somebody says, well, how's all this going to work? So anyway, that's just you'll pardon the pun, a plug for 3D plugs. And someone's chimed in on the chat. Yeah, Bill wants to know how the symbols show up in plan. They look just like this. So this is a viewport on a sheet layer. I'll use that to navigate over to the floor plan. And, here they are. This one got sent to back. Oh, shouldn't be here. So this is what the receptacle looks like in plan when it's in ceiling mode. This is what it looks like in plan when it's in wall mode. Right. Ceiling mode right there. And you can see I can attach a little note to it that will show up on the plan. So so there you go. So here we've got on the island, we've got two of them. They're stacked one on top of the other. But if we go back to that kitchen view, hopefully they're not buried and you can, yeah, there they are. One on top of each other in this narrow little sort of blind that gives us our island access. And then sort of marrying ducts and switches, let's look at this fireplace. So we've got this freestanding fireplace here, and it's of course gas burning, but it's vented. And so we modeled, get to the proper tool. So we modeled the fireplace. In this case, I just used the parametric fireplace tool and typed in all the parameters. So this is another, it isn't in the MEP palette. Where does that live? I think it's in furnitures and fixtures. Yep, there it is. Let me pull that out. There's your fireplace tool, and you can make all sorts of fireplaces with it. The model's not super detailed, but if you can get a cut sheet from a manufacturer, we can specify the height of this base, what the opening width is, whether it's two-sided, right, one-sided, whatever. And you can see that from the manufacturer, the vent sleeve is off center. So again, whoops, sorry, wrong save view. I apologize. So here we've got this extrusion that's just a sleeve that conceals the actual flue. And here's the flue. That's a group that we modeled using, yeah, you guessed it. There's the HVAC vertical elbow. There's the vertical duct. There's another vertical elbow. There's another vertical duct. So we just kind of modeled up that path so that we could assure ourselves that that this would work, that we could have this flue pipe centered on the clear story window, and centered on the fireplace, that everything would be happy. And we also, again, back to the photographs. If you look at the website, there's some really great tile that just um, faces this entire fireplace mass. And so what we did is we just sort of wrapped it um, with this black painted uh, trim all the way around. And because we needed to meet our code requirements for outlets, we put the outlet in the side. So, here's the outlet sort of set in the trim discreetly so it doesn't mar that glass, which was really, really quite nice. Oh, another question in the chat. All right, so Dick wants to know if you have 4 switches, which are 3-way and a dimmer, how do you get the plan view symbols close enough to look right in 3D? So, Dick, am I understanding that you can put yourself off mute if you want to phrase your question directly?
Yeah, because when I have those symbols, this the notations take up so much room. I can't get the symbols close enough that if they were in 3D,
Yeah.
they would look
Yes, yes,
fine.
yes. Right, right. That is a great question because let's look at that in let's look at that in 2D. So a couple of things I should mention is that I find that the symbols that Vectorworks generates, like this switch symbol, they're a little large graphically. And so one of the nice things is that there's this 2D scale factor field for the switch symbol, and in fact for the outlet.
Okay.
And so I routinely, I don't know if you can see that, but I routinely, just as a default, set mine at 0.6. So a little more than about 2/3 the size that Vectorworks would make them.
Okay.
Here's how big Vectorworks makes them. They're huge.
Yeah. Yeah.
So that's how I get them close enough to so that they read properly. And then the other thing is that if you highlight one of these puppies, right, and you go to your text menu, you can set your font size and assign the font from the text menu or just from right here from the text quick menu in the view bar. So Calibri is kind of our kind of workaday font, and I do it 6 point. And then I can just hover over this and then move that D off the line.
Yeah.
And so I make it 6 point text, and that covers the size of this note, right? Or that note. And then I make it 0.6, and that covers the size of the graphic. That S is not actually a piece of text, it's just a polyline.
Right.
And then what I find is if I space these 2.5 inches apart, or I guess these are 2 3/4, 2.5, 2 3/4 is apart, then the 2 plates will be touching in 3D. Because when you change the scale here, you're just changing the scale of the 2D representation. You're not changing the scale of, let's go over to the 3D view here. There it is in 3D, and you can see got a little sloppy there. There we go. Now they're touching. Right. So the tool doesn't let you do like a 3 gang or a 4 gang or a 5 gang. You're just going to have 2 or 3 or 4 of these,
Right.
side by side, and it'll give you a little telltale line. But again, no one really needs a, no one really needs a super detailed. I mean, I guess if you were doing a photorealistic rendering, you'd want to substitute something that looked like a real light switch, right? But for design purposes and being able to visualize, okay, where are these things, right? And then you
Yeah.
want to be careful too. Like, here's something I'm just going to tell one on myself here. Here's one that was sort of not properly placed. You can see a very faint line here that I'm hovering over. That's the gypboard. And this one was placed on the frame wall rather than on the gypboard. So that's a good argument for inserting these in the wall, which I don't typically do, right? But that little piece of mistake here, if I hadn't done that, then wrong one. There we go. right, then I would have noticed that this and this were not at the same height
Right.
as I was driving around the model. And I that's actually one I did not catch. And that is entirely on me. The contractor was just reading the drawings. So that would ended up being a couple of inches shorter than it should have been. But there you have it.
Okay.
Francois?
Didn't realize you could scale them.
Live by the model, die by the model. Yeah.
So in the 2D version, well, actually in the 3D version of the outlet, does it show the back box? Because you want to avoid having a switch on both sides of the wall and having the back boxes coincident with one another.
No, you're going to have to know that.
Okay.
Yeah. 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 And, you know, as a matter of course, right, I don't put them right next to the jamb because I know there's one or two studs, you know, at that
Right.
doorway. And so sometimes I'll just, you know, I'll stack them one on top of the other, right? That's kind of a design move to just stack two switches on top of each other. Or you can get those, you know, more expensive switches where there might be two or even three switches in a single box, if you need to. So yeah, they're not, these are relatively lo-fi models. It's not that they're going to solve the design problem of where to put your switches. Like Vectorworks will happily let you put a switch right next to a pocket door pocket. You know, if
Well, I don't know
it's
how many
really,
years ago I created my own symbol for a 3D switch just for that reason, uh, because I don't want to, I can see myself making that mistake.
yeah, but unless you've got like X-ray vision, which okay, so you do, but unless you've got X-ray vision, you're not going to necessarily see that that's anyway. So yes, sure, you can certainly build your own symbol, right, and do it that way with a record format. But I just find just using this as opposed to just a 2D symbol is really it's worth it.
Right.
And you'll thank yourself in CA, except when you make a mistake, and you know, like this switch right here. And of course, it's being recorded and on YouTube for all posterity. So there you go. All right, I'm going to look at another sort of more. Well, let me before I move on. Um, any other questions on what I've shown you so far? Looks like I lost my file. There we go. I'm back. Okay. Okay, let's look at another project here. This is one that we finished about a year and a half ago. It too had sort of some ducting modeling going on. I think all the ducts may be turned off. Christopher, if I remember, you did a whole duct modeling um, for this project because, of course, again, we had vaulted spaces and sort of pinch points. We created a sort of a scissor truss. I don't know if you can. There we go. All right. That's why it's live. So, you know, we created these scissor trusses or sort of false ball things so that we could get our duct work around over the screen porch and all that. But that's not what I wanted to show. Let's wait for that. There we go. Okay, so in this case, we had let me turn on all my classes. Kind of see what's going on. We've got a wood burning stove. This got modeled as a no, it is a we have a wood burning stove inside the space in this sort of stone alcove that we created below the clear story. And then outside we have just a regular old fireplace. And it turns out that there are roof ridges, and we need to decide which side of the roof ridge that wood burning stove is going to vent versus the fireplace. And so again, being able to model all of this with the ducting tool was just kind of nice because you know, you could rotate these things about a point and change the angle, so that they don't necessarily have to be, you know, orthogonal to your building grid. All right, you can see this is kind of coming off at an angle because the fireplace is obviously centered on the ridge, and we probably don't want the flue pipe to be. And then again, with the wood burning stove, we needed to plot a path through the attic for that to, you know, miss this little ridge, miss that valley, miss the other ridge, and so forth. And just being able to model that was helpful. And then the stove also has an air intake. And so we, again, use a series of little ducts based on the manufacturer rules on how far it could go, how many 90-degree turns. So here you go. There's an HVAC straight duct. It's 4 inches in diameter. Here's an elbow. It's 4 inches in diameter with a 3.5-inch inner radius. There's another duct. There's another elbow, and there's another duct, so that we can see, you know, just exactly how is this thing going to vent through the wall without having some ugly pipe. And so that's that. And then in this case, just because I'll just mention it since we were also talking about fireplaces. In this case, I didn't build the fireplace with the fireplace tool. This is an isokern, and those have very specific dimensions. And so we sort of built a symbol of an isokern fireplace and just kind of stacked it all up. And that's also the flue, is the 20-inch flue is just also another short piece of duct that we know that we have to tie into. So you can mix and match. You can do, this is just an extrude. Here's an extrude. Here's a shell. Here's another extrude. Here's a shell for the fire brick. But we went ahead and stuck in an HVAC duct there. What is the setting for rendering? Oh yeah, good question. So these are, this is a shaded render. So my rendering is shaded. And then my shaded options, my shaded rendering options, or I'm showing textures, colors, shadows, and I'm drawing edges, sometimes with a 1 or sometimes with a 2 pixel thickness. If you want people to think you're working in SketchUp, give it a 2 or 3 pixel thickness. I'm usually happy with 1. The one time I will beef up the pixel thickness beyond 1, sometimes that'll go up to 4 or 5, is if I'm outputting a rendering to print or to PDF or a PNG or something like that, because the lines will show up thinner in the PNG than they will on screen because it's a higher resolution. So that's when I punch up the thickness of the edge rendering. So again, yeah, you can. Yep.
Speaking of the line weights, I haven't looked at this in a very long time, but does the Vectorworks have a way of doing what we call profiling, where the outside lines of an object are heavier than the lines that are edges within the outline that you're looking at, sort of like a cube? The lines facing you are light and the outside lines are heavy?
Yep. Not yet.
Not
you're
yet.
talking about this. Yep.
Well, but in a 3D model, so that the edges that are facing you, that you can see both sides of the edge, are a lighter line, and can't see both sides of the edge, like the outside edges of a cube that you're looking at from a diagonal. Those are heavier. We call that profiling. That's what we called profiling years ago.
Yeah, I think profiling has a different meaning now, Phil. Maybe you want to call it depth queuing.
Say it again?
You want to call it depth queuing.
Depth queuing.
Terrible joke. Sorry.
Oh.
Very, very, very insensitive. Okay. Uh, a- and then lastly, I'm going to look at a commercial project here. This was a tenant finish out space that I worked on a few years ago now out in Bee Cave. This was a cold gray box that it was basically a dressed up pre-engineered metal building. And my client um, leased the space, and it was a uh, retail space for bikes, a bike shop. And so there were changing rooms and bathrooms, and all the usual kind of commercial stuff. And because it was a fairly open plan kind of concept, all the ductwork was going to be visible. We didn't have like a tegular ceiling where all of that was hidden. So how we modeled that was important. And uh, Don will know this mechanical engineer, um, and the mechanical engineer he was fine, but he was pretty old school. Like everything was 2D drawing, and there was certainly no 3D modeling going on. And so where the ducting was important. At one point, we were examining, trying to see if we could get some skylights into the design to reduce energy loads and increase energy efficiency, and also have better lighting of the product. I gotta say, skylights are a real hard sell to retail um, clients. I'm not sure why, but everybody has this sort of skylight leak phobia. I don't know. You ever been to a Walmart? They got skylights everywhere. I would think if they leaked, Walmart wouldn't use them, and neither would Home Depot. In any event, uh, so because we had, the mechanical um, drawings from the engineer, but not a 3D model, and because we wanted to do the lighting design and have the engineer validate it rather than the other way around, what the ducting was here was actually quite important. And so here's a view of the interior. So see, the ceiling ended up being black, of course, and you can see we modeled all the light fixtures. Some of them were really quite primitive, like there's that's what is that? Yeah, that's just a little 4-foot LED, but I'm sure if we go into the model of that, we will see that it is just a real basic extrusion. Oh, I made it as a floor, even crazier. So just being able to have all of these objects as a 3D hybrid symbol is really quite useful when your ceiling gets really quite cluttered. So all the ductwork that you see here, that's all modeled in Vectorworks. We dropped in the MEP engineer's drawings as a PDF, and then we just kind of read the ductwork, very inefficient, read the duct sizes off of his drawings and schedules. And then all of this that you see, like this transition from a round duct to a square duct, where we've got this vertical duct that's coming off of the rooftop unit, and then transferring to round duct for a better appearance inside. All of that is based on using these components from the ducting tool, the vertical elbow, the vertical duct, the horizontal duct, and so on and so forth. So that's that was pretty cool. And really, generating that it wasn't that difficult. I mean, it was pretty quick to just trace over the MEP drawings. So we ended up having 3 RTUs here, which I didn't bother modeling because this was essentially an interior space. So here's one vertical supply duct from an RTU. You can see that I'm colliding with the steel bent. So that's probably not great. I'm pretty sure we ended up moving that over slightly. Here's another vertical from an RTU, and then here's the third RTU there. There was mezzanine. And then if we just look at this, I think I made each of these a group. Yeah, so we've got a couple of dressing rooms here. So, you could go ahead and work out whatever angle you need for your duct. So here's this little elbow, here's another elbow, vertical ducts so that we can drop into the dressing rooms. And again, all of this is being modeled both to help us make sure that we don't have any collisions or crashes, or I'm sorry, clashes. Also very helpful for the owner to be able to see all of that if they've got some misgivings about spiral ducts or vertical ducts. All of these big ass fans we modeled, and we based the height of those fans on sort of their position in space and how far we thought we needed to get clearance from the duct. So that was all super helpful to be able to use this tool, again, really as a design tool, right? It's not like we cranked out a mechanical plan for construction. That was all from the MEP engineer. So let's see, got a new message. Yeah, so yeah, Dick wants to know what this looks like to actually use that. So yeah, that's a perfectly good suggestion. So let's go ahead and start a blank document. My units are already at a quarter. I don't have any classes in here. It is just a blank document. So, I'll just draw this duct with the duct tool. I'll just hit OK. It'll just give me whatever duct I want, whatever the default is. Let's go ahead and make that a round duct. We'll give it a diameter of 18 inches and specify a length, let's say 12 feet. And from the object info palette, I can also give it a rotation. I'll give it a 30-degree angle. And then let's go ahead and give us, let's do an elbow. I'll just stick that elbow here and snap to there. Let's make that elbow also round and give it a width 1, diameter. This is width 2, actually. We'll make that 18. Oh, it's very nice. It just did that right for me. We'll give it a leg of, say, 18 inches on both inner legs. It's already picking up that 60-degree angle, but let's make it a 45. Okay, I can show it lined or unlined, uninsulated, whatnot. And of course, once I get all this set up the way I like, I can save this as a style. So there's my round duct. Let's make that inner radius 24. There we go, that's better. And I think I want an 18 here and not lined or insulated. There it is. And then if I wanted to transition down to a smaller duct, you just stick that transition right there. I'm just using my constraints to drop in a perpendicular. That's going to be round to round. And we'll start at 18. And we'll go down to a 12. And we'll make that transition 3 feet. There we go.
Wes, while we're putting the pieces together, could you use the eyedropper tool to take the characteristics of the 18-inch duct to make it an 18-inch elbow?
No.
No, okay.
I can do this. I can take that duct, right? Or I could just draw a horizontal duct off of that, right? And I could pick up these attributes and drop them on that one, but I can't change the attribute. These are actually different objects, right? They're all called HVAC ducts, but they're just different objects. So then I can change this one to 12 and give it a length of 6 feet. Right? And then at the end, I can go ahead and place a diffuser here. I can make that, I've got a menu of choices. We'll do a round supply air, give it an 18-inch diameter. So there's that. And I'll drop this one here, and that one here, and that one there. And let's do 2 more. And then I'll take these 5 and align, distribute the spacing in both directions. And then I'll just get rid of these 3. So I got those. And then in a front view, everything is all crazy. So what's going on here? I didn't show 3D detail. Right. Go ahead and group all that. So I might take those and move them up 3 inches, I'm guessing, right? Take these, move them down 3 inches. So the ducts aren't sticky. You're not inserting diffusers in a duct the way you would insert a window in a wall, for example. But pretty quickly I can come up with this kind of stuff. The diffusers, they're not super detailed, right? They're a little blocky, but they get the job done. The ducts aren't even hollow. That's fine. I mean, if I really wanted to, I could take all of these things. Let's see if we'll see if this even works. Let's try that. We'll go ahead and model and add solids. And it gives me a single solid object. All right. And I can even take that using the 3D modeling tool and shell it. I'll give it a thickness of 1/2 inch just for fun. I'll tap the end here and hit return. No, it didn't like that shelling. Didn't let me shell it. And then, of course, now it's just a solid addition. If I double click and edit that solid, it takes me back to the component hybrid objects. But if I go into top plan view, it's no longer showing me the 2D information for those. So I need to ungroup that for that to happen. Yeah, so let's go ahead and we'll do a vertical. Go to top plan view. We'll do a vertical transition here, and that'll be a round turn up. And let's make it 18 and an inner radius of 18. I think that's okay. So there it is. Rotate it, put it in position, go to a front view. Now I can't just take this horizontal duct and rotate it to make it vertical. Can't change the angle, right? My ducts are level or vertical, but I can go ahead and drop a vertical duct here, snap to there, make it round. And 18. That's very funny. Make that 18 inches, right? There it is. And I can either move it up manually or I can just move it up 3 feet because that's what it is. And then again, if I want to have a vertical transition, can do those too. And I gotta find that. I know it exists because I've used them.
Is the radius tool, is the radius on a corner, is that the outside, the inside, of the center line?
The inside radius,
Inside radius.
inner radius. Yeah. So I can do that 12, 6. And I can move it from here to here, so on and so forth. I might have to look at my old file to remind myself how I did a. It's kind of nice. We're inside the duct. Did I do a vertical transition? Maybe I didn't.
So it's basically a process of just putting together parts.
Yep. You're not like drawing a path and then having Vectorworks convert it to ducts.
I think that's what I wanted to see.
I'm sorry?
I think that's what I wanted to see.
Yeah, that would be cool. There's probably a script that could do that, but no, it's very much a Lego approach here. Yeah, I think for the verticals, what I did is I just let my vertical duct just hang down and then I just feed into it with a horizontal. But you can see here once I get outside the showroom, when I'm in the kind of the bike shop and all that, we've switched everything to just, less expensive rectangular ducts, and then those elbow pieces are made and so forth.
Unrelated to the drafting, your discussions with the mechanical engineer, was it you that basically decided where you wanted the round ducts to be for aesthetic reasons, or did he locate them and you just take them off the drawing, his drawing? In other words, how much control did you have over the placement of where the round ducts were?
Yeah, probably not a lot of control. I don't remember offhand. I mean,
I just find it very odd that you have one duct on the left, that's a duct with diffusers directly underneath it, and then the one to the right is with branches. That's kind of expensive way to do it. Why didn't you just put the duct right over the other ones?
part of that was predicated on where, since this was a cold gray box, we had some limitations. If I may be misremembering this, Bill, it's been a couple of years, but I think we had some limitations on where we could put the rooftop units, the RTUs.
Right.
And so that was one of the parameters that the engineer had to work from, is where we could get the RTUs. So that was one factor. And then I didn't want a whole ductwork over this cash wrap. I wanted the suspended ceiling to be sort of free and clear. That might have been a factor why those ducts were displaced. I'm a little fuzzy on that. See if we have anything in. Oh yeah, a couple of things in the chat. The ducts are solid. To Ashot's question, they. Let's look at that. I don't think these are. You can see that if I use the clip cube, you can see that duct is solid. So, I'm not sure what you would have there if not a cap, maybe a diffuser. So you can, there's a There's a wall-mounted diffuser. And I need to find that. And now it exists. Maybe that's just a setting. Yeah, there's my wall-mounted diffuser. So if I wanted to put a diffuser at the end of this run, I could do that. And of course, I can make that diffuser smaller. Whatever. And of course, all these things you can attach data to them. You could build a schedule if that's what you wanted to do. But primarily we use it for modeling as a design tool and for clash detection. All right. Let's see. Looks like one more question. It's not a shell. It's a solid. We look at again, if we look at a clip cube, that section is red. That means it's solid. If it were a shell, then when I ran the clip cubes through it, it would show accordingly. All right, everybody. Well, thanks very much for coming by. And if there aren't any questions, I will catch you next month.